No, it's not that simple. It's not that simple. Yeah, but the thing is, like, even if you're staying home for those 2 weeks, school keeps moving forward. Lessons are still taught. Still got to keep up on the information. Assessments are still given. Like, it's much more difficult, in my opinion. It's much more difficult to do virtual school than it is to actually be in school on the average. I said on the average. That I know there's always going to be an exception to the rule. You know what I'm saying?
There's a lesson, so, but like, I don't know. It's just work from home. It's something like I can pace myself. I'm not like rushing in school. I don't know. There's something about it. I like it now.
I understand that. I totally get that. But then I'm saying, like, for example, for someone like my son is 6 years old, and he goes to school on LBI, and he did virtual this entire week. EJ, Ethel Jacobson. No. I gotcha. That's a bit farther down.
It's so cool.
Yeah.
It's like 110 years old.
I know. But he did virtual this past week and is doing virtual this upcoming week. And now my son is he's average when it comes to pretty much everything across the board. There are certain things that he definitely excels at. But when it comes to like basic stuff, because he's 6, he's in first grade, like basic reading and writing and math and whatever. It's just like he's with everyone else, But being at home, he finds a lot of opportunities to kind of like meander the house,
I feel like once you get to high school, that's not everybody. I mean, not in middle school.
Like 7th grade.
And when you're older, I think if you're responsible enough, you can do it.
You'd think. Now, like I said, on the average, I would say that students do better in school. And I said on the average, and obviously there's exceptions to that rule. I could say on the average adult male height is 5'10". Clearly, I'm below average. It's just the way that things are. But that's a statistics question. Anyway, back to this. I feel like people are missing, and then someone shows up. So, we have, as of today, 1, 2, 3, 4, 5, 6 class periods until midterms. 6 class periods until midterms. A couple of those class periods, of course, we're going to be reviewing in preparation for said midterm. So there's limited information left that we are going to be covering before we actually knock this thing out. It's going to be fantastic. And then you'll be done with half your school year. Yay. No one's excited. Okay, fine. Now, what I would like to do, first and foremost, is I would actually like to start off with the quizzes. This quizzes is based on some information that we learned both before and after winter break. Now, this quizzes will be based on composition functions. This is a practice. I want to be very clear. This is a practice. So I want to see what you can do with it. And then after said quizzes, I would like to go over a couple of those problems that we are going to put into our notes. Probably going to go over the red-colored questions, but we'll get there when we get there. And then after that, then I do have some slightly new information to introduce to you in regards to where this chapter is going. So, hold on. There's a bell.
Attention teachers, Mr. Orbit's gym class was running late, so any students from Mr. Orbit's PE class will be running a few minutes late. Thank you.
Okay, we'll figure that out. They could always, if that happens, they could always join the quizzes late. But what I'm going to need from you is kind of 2 things. Number 1, I'm going to need those Chromebooks out, open, logged on in order to knock out said quizzes. Number 2, I am going to suggest that you have scratch paper or your notebooks ready to go in preparation for this quizzes that I would like you to do. So first things first, we're going to try and knock out said quizzes. And then I would like to review a few questions from said quizzes, but you got to get yourselves logged on. For those of you in the live stream, I'm going to put the code into the chat once I have this thing loaded up on the board. There we go. Eight, 2, 7, 5, 6, 4. 8, 2, 7, 5, 6, 4. There we go. No. This quizzes is a practice quizzes. This is a practice one. Eventually, of course, my assessment, I will always let you know when something does count, whether I name it a minor or a major. But this is nothing more than a practice quizzes. To kind of go back to the education conversation, for example, on the average, they would say that most people would succeed in life if they achieved a bachelor's degree or some junk like that, okay, from college, on the average. But that doesn't apply to everyone. That clearly doesn't apply to every single individual person. Two of my best friends, one of them never went to college, and he's earning 6 figures. I have another friend who didn't go to college until he was like 28, and now he has a PhD. There's no... They say, on the average, do this and you'll be successful. Of course, that's on the average, but there's always going to be an exception to that rule, is my point. And I have 2 best friends who clearly are exceptions to that rule. Just like with online versus in-person learning. Whatever. I don't know. I need to get off my soapbox. Oh, she retracted her message. Okay. I only got 4 people logged in. No. 4 people. And like I said, I strongly suggest having scratch paper. There's going to be a few problems that you may have to jot out on paper before you actually pick whatever answer you're going to be going for. What is this? Yeah. Where'd I put what? Post what? The quizzes? I didn't post it anywhere. You just go to joinmyquiz.com. Sorry. Joinmyquiz.com and then do the little code there. It's just a practice one. Oh, it disappeared. It's down there now. It said Joe Pat Bill Dinosaur. Okay. I know. I don't like it. I don't. Hate it. Makes me cry. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 of you here. I got 9 of you signed in, but I know that some of these people are the online people. The second mark period ends the last day of midterms. It's the last day of the second mark period right here. Mm-hmm. Third mark period starts Friday the 29th.
You know when that ends?
I have it on paper somewhere. Oh, somebody left. AP stat.
Probably April, right?
Second?
Like April?
Something like that, probably. Something like that.
Like right before spring break.
That I'm not sure of. I don't know when spring break is, actually. All right, I'm going to click start on this. If you have not signed in, January 28th, the last day of midterms. I'm going to click start on this thing. If you haven't joined yet, the code is going to be at the top of the screen, and it will still be valid. Of course, I'll be coming around to make sure. Let's get started. Probably like another 2 or 3 minutes. Oop. No, he appears to be absent. Okay. Bye-bye. Do. Mazda. All right, let's take a look at this. Now, looking at your percentages, I'm not going to go over every single question that is on here, but I would like to hit some key questions along the way. I definitely think I want to hit number 3. Let's see. Possibly that one. I definitely want to hit number 3. I definitely want to talk about, not that one, number 8 and number 5. Yeah, so 3, 8, and 5. Okay, so what I'm going to ask you to do is this. I am going to put this information into my notes, so I'm going to ask for you to have those notebooks out and open. So I'm going to call this Quizzes Review. I'm going to have a different title for you in a little bit once I hit the newer information. But we're going to call this a Quizzes Review. Today is the 7th. First question that I want to hit is definitely number 3. I'm going to write down some of this information, and then I'm going to flip my screen over so you can see exactly what I wrote down, because this Quizzes website isn't really good for showing this problem. and they want f of g of 4. So here is what I wrote down. This is number 3 off of that quizzes. There are multiple ways of going about this problem, multiple ways of knocking out the correct answer. Now, if I looked at the actual choices, the choices on this problem look like numerical values. The answer is going to be a number, but what number that may be, well, that remains to be seen. Like I said, there are 2 ways to go about this. I'm going to show you one way up on my notes right now. They want to do f of g of 4. Well, first, let me just see if I can't figure out f of g of x. And then after I get that, perhaps I can plug a 4 into it. So I'm going to do f of g of x. Nice. Look what I just wrote here. I just wrote a little bit of a framework. This framework represents f of x. It is the outside framework that f of x actually is. F of x is supposed to perform x squared plus x, the variable squared plus the variable. Well, instead of writing that variable, I wrote a blank. It's blank squared plus the blank. It's the same thing as x squared plus x. It's just that I'm replacing that x with something else. And what I'm replacing it with is the g of x function. I took that g of x and I shoved it inside of the f of x function. You ever have turducken? You know what a turducken is? Ever heard of a turducken? It's a chicken stuffed inside of a duck, stuffed inside of a turkey. And then they cook it, and then you eat it. Turducken. Anyway, back to this. One equation stuffed inside of another equation. Now, you could simplify this if you wanted to. You would actually have to do 3x plus 1 times 3x plus 1 in order to do that properly. Now, I'm not going to do that for this problem because all they wanted was for me to plug a 4 in. So what I'm going to do is I'm actually physically going to plug that 4 in for the x right there. I'm going to simplify this down in a moment, but I just wanted to show you this in-between step of actually plugging that 4 into the function. Order of operations, 12 plus 1 is 13. This should give me 13 squared plus 13, which is 169 plus 13, which should give me 182. I'll double check my answers on quizzes in a moment, but it looks like that works. Now, I am going to show you an alternate way of doing this in a moment. I'll write it on the board in red, and then I'll erase it. But I wanted you to see how this thing kind of played out. One function stuffed inside of another function, and then that number stuffed inside of the variable. If I look at the choices here, then yep, clearly 182 is indeed the answer. A lot of people chose none of the above. That makes them sad. But that's what that thing does. Here's another way of looking at it. Another way of looking at this problem could be to first perform g of 4. G of 4 should be 3 times 4 plus 1, which is 13. G of 4 is equal to 13. Now, they want to know f of g of 4. Well, I know g of 4 by itself is 13. So in reality, all I would have to do is f of 13, which we already know here is 182. That's just an alternate way of looking at it. You could look at it from the variable perspective. You could look at it from the numerical perspective. Ooh. Sorry, I'm just reading comments. Either way, gets you the same answer. Let's take a look And number 5. Scroll, scroll, scroll. There we go. Similar problem. I'm going to write down the important information. I'm going to write down what we need for number 5, which is P of x is equal to 3x plus 4, and Q of x is equal to 2x squared. And they wanted that. Good. Flip. That's the question that they asked. P of x is equal to that function, 3x plus 4. Q of x is equal to 2x squared. And they want to know Q of P of negative 2. Now, I'm going to do this the other way. I'm going to do this the numerical way. I'm going to break it down piece by piece. First, let's figure out what P of negative 2 is. That's the inside of the function. If I'm going to perform P of negative 2, it should be 3 times the input plus 4, which if you did that correctly should spit out another negative 2, because this will give you negative 6. Negative 6 plus 4 will give you negative 2. So P of negative 2 by itself is equal to negative 2. That is just pure coincidence. That doesn't always happen that way, but that's what they get. So now they want to know Q of that number. They want to know Q of, well, P of negative 2, which I already know that that's negative 2. And it's a matter of calculating that correctly. Careful when squaring a negative. Ultimately, this should give you positive 8. That should give you positive 8. And I'll double check my answers and quizzes in a moment. Chapeau. Chapeau. Yep. Again, they get none of these, and 3 of you chose that. Let me scroll down. Which one was it? Wasn't that one. It wasn't that one. It wasn't that one. Oh, I must have missed it. Regardless, let's go over number 15. I'll go over number 15 and we'll kind of wrap up the review there, and then I'll talk about the new stuff I want to talk about. I know number 15 was a yellow question, but I'm running short of time in getting this lesson started. F of x equals x squared minus 4. H of x equals 3x plus 3. And they want you to find that. Looks like 50% of you got this one right. This is what I wrote down. F of x equals x squared minus 4. H of x equals 3x plus 3. And they don't give you a number to plug in. They just simply want you to simplify f of h of x. F is the outside layer. It's the outside shell. The shell of f of x, well, it should be x squared minus 4. So I put a blank squared minus 4. And I'm simply going to take that 3x plus 3 and shove it in there. Now, you have to be very careful here, because in order to do this problem correctly, you got to multiply 3x plus 3 times 3x plus 3. You can't distribute. You're going to have to do 3x plus 3 times 3x plus 3 with that minus 4 kind of tagging along at the end. Now, you could use foil, you could use a 2x2 box, you can do whatever you want. But ultimately, if you did it correctly, it would have foiled out to that quadratic minus 4, ultimately giving you this quadratic when you simplify it farther. We have to be very careful with these problems. There's not much room for error. There's not much room for error. So we do have to be careful. Okay. As I mentioned, there's a newer concept that I want to introduce to you today. That was more of a review, and now I want to introduce this newer concept. This newer concept we're going to take slowly but surely. I'm going to title this brand new title. Let's call it Graphing Square Root Functions. And right off the bat, let me just write this. Now, square root functions. I have no idea what grade level you were in when you were first introduced to the concepts of square roots. When were you introduced to squaring things? It had to be elementary school, right? Late elementary school, maybe? You learned your multiplication tables, but I don't know when you were first introduced to like exponents and square roots. I don't know. But like we're familiar, it's been a while, right? You're familiar with you know what a square root looks like. You know what a square root does. But now we have to look at it as we are graphing square root functions. Graphing square root functions is a slightly different type of beast. Now, what I want to do first and foremost is I want to go to the graphing calculator. You don't have to worry about going to yours. I'm going to bring it up here. There we go. Let's clear that. Let's throw in the square root of x. And now I'm going to graph this thing. Let's take a look at what it does. Chapow! This is the square root of x. You can see where it starts. You can see where it curves. I want you to think of the square root of x as a parabola on its side. I want you to think of it as a parabola on its side. Now, it's not actually a parabola on its side because that bottom half is not there, and that bottom half should not be there, and it isn't. I don't know who taught you Algebra 1. I have no idea when you learned Algebra 1. Doesn't matter to me. It's been a couple years. I'm just going to ask because I usually do. Did you ever learn a concept known as the vertical line test? You did. Do you know what it does? Okay. A vertical line test, well, tests whether or not a graph is a function. It's testing whether or not a visual graph is or is not a function. Basically, if you drew a vertical line and it went through more than one point, it would not be a function. If I drew a vertical line here on that curve, it would go through 2 points at various locations. Not everywhere, but at various locations. And because of that, the bottom half of that line does not exist. The idea of being a function, I think they simplified it down to, for every input, there's exactly one output. And if that bottom curve were there, you would have 2 outputs for one input, and that would not fit the definition. Now, let me draw something, and then I'm going to give you a slightly different formula. Chapow. First of all, let's just sketch this over here. This is your typical square root function. I want you to think of it as a parabola opening up to the side, but it's only half of it. Now, that line does not flatten out. That curve does not flatten out. It technically, like a parabola, goes up and out forever. That's what it does. It goes up and out forever. Now, I have a standard square root function. And a standard square root function would look something like this. Now I'm going to draw this out, and then I'm going to explain what the heck is going on here. Let me zoom in. This is your standard square root function. F of x equals a times the square root of x minus h plus k. H and k are back. They have not gone too far. H and k remain. H and k hold similar properties to what they did in the past. H and k are going to be important to identify. Now, we're going to talk about what H and K actually do in a moment. Give me two numbers, any two numbers. 6 and 7. Okay, let's see. Hold on. 6 and 7. You gave me 6 and 7. Positive 6 and positive 7. Watch what happens when I put a 6 and a 7 in for the H and K. Watch what happens to it. I just want you to see what happens to it because this thing is going to move. And I need you to identify where it's going to move. Go back to here. Go back in there. So you decide. Plus 6 or minus 6. Doesn't matter. Sure. And then plus 7. Notice right here, again, with your calculators, because you guys are going to have this issue as well. You got to make sure that whatever number goes in the square root is in the square root. The square root bar is going to extend over it, and you can see that little arrow right there. But any number that's outside, you better make sure that you type it outside that square root bar. You got to be very careful where that thing is. Let me graph it, and let's see what happens. Chapow! It moved. Now, you told me minus 6, so I wrote it in as f of x equals the square root of x minus 6 plus 7. Where did it shift? Say again? It did not go up 6. It did not go up 6. It's a little hard to count, I know. But the numbers in the equation are going to tell you approximately where it went. It actually went up 7. Where else did it go? Over 6 in what direction, though? To the right. Even though you told me to put it in the minus. You said, well, make it minus 6. Okay. And even though I put in the minus 6, it moved to the right. There is a reason for that. There is a reason for that. If you look at the original equation, which I just flipped up on the board right now, within that square root function, it is x minus h, as it has always been. And since it's x minus h, x minus 6, that h value is positive. That 7 at the end remains a 7 no matter what. But the h and the k in this case are 6, 7. We can change it up again. Give me two numbers, one positive, one negative. Different from before. -5 and 8. All right. I'm going to put it as... I'm going to just clear this whole thing. There we go. Square root of x plus 8. Now notice again the little arrow as I'm typing it in. I got to tab over to the right. Sorry, you said -5? There we go. Look at this. Graph. I can hit trace. It'll bring the equation up on the top left. Did it shift to the left or the right? How many to the left? How many? Yeah. It shifted 8 units to the left, even though it was plus 8. And then it did a shift up or down. How many? Yeah. The -5 caused it to shift down. That's what this thing does. You can make this thing do anything. Now, I want to write down a little something about H and K, and then I want to show you what the A does. So let's go back to here. Zoom out, zoom out, zoom out. Here we go. First of all, H and K change the starting location of the graph. H and K, or H comma K as an ordered pair, change the starting location of the graph. If you can identify H and K based on what the equation looks like, then it will definitely show you where that graph starts. Furthermore, scroll this up a little. The graph shifts H units horizontally. H units horizontally. It'll move left or right based on that H value. And the graph shifts K units vertically, either up or down. I'm going to put a bullet point here in a moment. I'll move this up. I'm going to put a bullet point here in a moment to kind of reiterate something about the H value. Oh, do you need this one? Let me try to move this a little. Or zoom out a little. Here we go. I'm going to put a bullet point down about the H value, because the H value, depending on the way that it looks, you have to recognize the fact that inside that square root function, it is x minus h. So you have to take that minus into account when figuring out what the H value is. And I'll give you a few examples of that in a moment. And we kind of guess where it's supposed to go. I'm going to put a little bullet point here. Pay close attention to the sign on H. Pay close attention to the sign on H. The K value is what it is. If the K value is positive, it goes up. If the K value is negative, it goes down. But I'm just saying, pay close attention to the sign on H, because you have to determine what direction it is supposed to go. Now I'm going to flip over to my calculator in a moment, just giving people an opportunity to write that down as we begin to wrap this thing up. I do have one more thing to talk about with A, but we'll get there in a few minutes. Let me get rid of this top part. Move that up. Now check this out. Chapow! Go back over here, clear that, square root. Oh, let me show you one thing real quick. Check this out. Regular square root function. Look at the table of values for the regular square root function. This should make sense, because it's like, oh, looky right here. The square root of 4 is 2. Yay. The square root of 9 is 3. Yay. The square root of 0 is 0. Yay. Look what I get back here. Why is that? Does it what? Oh, yes. It definitely starts at the 1 point. But why am I getting errors back there? If you try to square root a negative, what do you end up getting? Say again? I. Square root of a negative is I. And you can't graph I on the XY plane. You can't. But you're right, the other half of that graph is not there. It's not there. We know it's not there because we see that it's not there. But I'm just showing you that there's a reason for the errs. Now, if I go back to the y equals key, let's see. I'm going to type in minus 5 and minus, minus 2. Some junk like that. Where is this graph going to shift? Hold on, listen very carefully. Where is this graph going to shift vertically? Definitely, yes, it will. It should shift down 2 units, and it will. Now, this is more of a rhetorical question. I want you to think about what the answer is in your own head. Do not answer out loud. Don't answer the following question out loud. Oh, there are people yelling in my hallway. What are they doing? Yeah, I see several teachers out there. There's something going on. We should go beat them up. I mean, go see what's going on. Anyway, back to this. Where is it going to shift horizontally? Where is it going to shift to the left or to the right? Now, don't answer out loud. I want you to look at the equation that I have on the board and answer in your own head. Where is it going to shift, left or right? Yes, it will go down 2, but where will it shift horizontally? Here, I'm going to graph it. Chapow. It shifted to the right. It was x minus 5. And because it was x minus 5, looking back to the x minus h, the h value is a 5, thus it shifts to the right. It's very strange to think about it, but you do have to pay close attention to the sign on h because it's going to determine the left or right nature of it. Let me insert something here. Check this out. Chapow! Look at this. Actually, hold on. Let me do one thing, and then I'll put this back. Let me draw something on the board because I want to show you this visually right here. Here's the graph that we just did. That was fun. Now let me throw that negative out front. Check this out. Let me throw this negative out front. Insert negative sign graph. Boom. The A value causes a reflection. But it's not just a simple some people think, oh, it's a reflection across the axis. Not exactly a reflection across the axis. It's just a vertical flip. That's all that it is. It's a vertical flip. It's not a vertical flip across the axis. It's a vertical flip to connect the other half of the parabola. That's what that thing does. Looks perfect. That's why I wanted to draw that line, because it looks amazing. One more statement I got to write down. One more statement I got to write down, and then I'm going to go find out what the heck's going on outside. I know. I just want to know what's going on. They're not following social distancing rules, are they? Here we go. Last thing. If A is negative, the graph will reflect vertically, but will keep the same h comma k. Let me zoom in on that. If A is negative, the graph will indeed reflect vertically, but it will keep the same h comma k. I want to make sure that you're aware of that. Okay. I'm going to say for everyone here and for everyone in the chat, pay close attention to Google Classroom, as I may be throwing something at you in the next day or so. I won't see you again till Monday. So if you do have any questions, please make sure that you are messaging me. The bell shall ring in approximately 2 minutes, but I'm going to sign off on the chat now. Everyone have a wonderful Thursday. Click. Chaboom.